All right, so we are going to use a couple things to prove some interesting things about triangles. First, we're going to use angle-angle similarity to prove that all 45, 45, 90 triangles are similar. And from that, we're going to be able to find all side lengths of a 45, 45, 90 triangle. And we're going to use Pythagorean theorem for that purpose. We're going to figure out that they're all they follow the same kind of rules. And so if you can figure out the shortcut today, it's going to save you a lot of time in the future. Okay. So here's a 45, 45, 90 triangle. Now, as we learned from our door hinge theorem stuff, if we have two angles are the same, the sides across from those angles should also be the same. So we know this is going to be a 60, 60, y triangle. So I know that this is 60 squared plus 60 squared equals y squared. So if I find 60 squared, and you trust me on this, we're going to leave the 60 kind of alone for a second. So this is going to be 2 60 squareds equals y squared. So if I wanted to solve for y, I would take the square root of both sides. And you're about to see why I kept it 2 60 squareds. So if I take the square root of y, I'm just left with y. And on the right, I can't take the square root of 2, but I can take the square root of 60 squared, and it is just 60. So I find that y equals 60 square root 2. It's kind of interesting. Okay, let's check this out. Let's see what happens when I change that side length from 60 to x. So here we have x squared plus x squared equals y squared. So when I add these together, I end up with 2 x squareds equals y squared. From here, I can easily solve for either x or y. And we're actually going to end up doing both. So I'm going to first solve for y because that's probably the easiest. So I'm going to solve for y on the left. So I have 2x squared equals y squared. If I solve for y, I just take the square root. And I end up finding out that y equals x square root 2. So y in terms of x is just square root of 2 times the x value. So now let's find out what happens when I solve for x instead. So over here I would divide both sides by 2. And I end up with x squared equals y squared over 2. So now if I take the square root of both sides, remember you take the square root of the top and bottom of a fraction separately, I end up with x equals y over the square root of 2. So y over the square root of 2. Now you can write it that way, or if we rationalize the denominator, this is the same thing as y square root 2 over 2. Depending on the problem, one of those is easier than the other. I promise. Sometimes one is easier than the other. Okay. So let's use that to help us out. So we want to find x and we want to find y. If we know this side of the triangle already, this is a 45, 45, 90 triangle. So 3 is across from the 45. That makes the x the other 3. So x in this case equals 3. To remember back to that pattern we just discovered, you can use that. But if you can't remember it, we can go ahead and use Pythagorean theorem. And because I'm assuming that I don't remember it, I'm wrong by the way, then I can use Pythagorean theorem here. So I know that 3 squared plus 3 squared equals y squared. So then I would end up with 9 plus 9 equals y squared. So I end up with 18 equals y squared. So I take the square root of both sides. And 18 is 9 and 2. 9 is 3 and 3. We can pull out 2 3's. So this becomes y equals, we can pull out the 3, square root 2. If you haven't figured out the pattern yet, strongly encourage you to think about it a little longer. Okay, so now I want you guys to go ahead and try this one. So you've got to find y and x. After that, I want you to go ahead and try it again here. You're given 4, I want you to find x and y. Then here, you're given 10 square root 2. For the hypotenuse, I want you to find x and y. Then we will meet back together at this word problem. All right?